Welcome to a new test and teardown video. I've just been to a flea market and look what I got, some more old funny stuff. And that one is a Grundig. It's a test oscillator or test sender, test transmitter. It's also called AS2. And its Grundig part number is 6031. This is written on the back. It covers from 0.1 to 115 megahertz in all those different bands. And I think this one is a carousel switch. And then we got the different color codes. It's actually quite nicely made with the color codes. And of course this is the output level. I believe this is the setting for drive to the output stage. It is tube based, but there's only 3 tubes in it and only 3 transistors. It's from the start of 1960. About that, I think the original design is as old as 1956. And look at that. So there's an X output and horizontal deflection. So I think this one is supposed to be connected to an oscilloscope, and then it will sweep both the scope and the frequency, and then you can perform bandwidth measurements and stuff like that on your scope. So it's a little bit like a wobble center or a wobble generator or sweep generator. And of course you can change the modulation frequencies and how much you want and all that kind of stuff. And this is a little bit annoying output connector. Luckily I got one of these from another project, so I think this one should fit here. Haha, and that is good. Then I will have to connect my ground for protection because the mains connector is not having a earth connection. I always use protective earth on old stuff like this. I don't want to get electrocuted. So let's try the first power up. Of course, here's my protective earth. And I connected the output to my scope, and I am now in 2.2 to 5 megahertz, and that should be 3 megahertz. I think I got no modulation and maximum output. And that is off. Let's turn on mains. Let's turn off that one. And yes, we got light. 45 watts. And oh, here we go. This one hammers up. That is weird. I was expecting this one to be able to go into the middle. I don't know if that is visible. Okay, it's still warming up. See, this is the drive. I didn't expect the output to be super duper nice and free from harmonics and all that kind of stuff. And this is, wow, look at that. I don't know if you can see this. It says 2.98 megahertz, and I just dialed this for 3. Wow, that is amazing. And here we go with our drive in the middle. So that means the dB here should be accurate. I'll of course check that, but frequency is good. And then what can we do with the modulation? Maybe we should try and play with. Okay, so that is 50 hertz of modulation. What are we doing here? That is interesting. So what kind of modulation is this? That looks a lot like AM. Ooh, AM with some... Ah, this is a sweep! Look at that! That is definitely a sweep. Funny thing. Ooh, here we go again. A frequency sweep. I will definitely hook up my spectrum analyzer and let's play with this and then look at the X output here as well. Aha, that is interesting. Sweepity thingy. What else can we do? That one is funny, right? So we're doing... Okay. And here we go. That's just AM. It also says this can do AM and FM, and here we go. This is called frequency modulation, and this is called AM modulation. Click no AM, and here is FM. It's so funny with the FM that it goes into this kind of funky stuff here. Probably is not that one. This one needs a little bit of massage. And then we got this horizontal thingy funny. Ah, that one doesn't work. So 50 Hertz works, but 800 Hertz is not working. Anyway, I'll try and play a little bit more with this. Yeah, I'm actually still playing around with this fantastic unit here. I'm having a few breakthroughs about this X output. So yes, it is the purple one down here, and that is the sweep. And I can, if I dial here, I can give you more or less. So this is for an external scope, sweeping something, and then I enable this FM sweep. So it is definitely using that one as the frequency sweeper. And then here we see on the, oh, let me turn off the AM. So here's now only the FM sweep. So yes, that is definitely what it is doing. If I turn off the FM, then I can turn on AM. And then it looks like this on the frequency spectrum. You'll see the different frequencies AM consists of, the modulation frequencies. And of course, if you look on a time display instead of a frequency spectrum, it's going to look a little bit like this. So yes, I think I will try and open it and see what's inside. Now that was actually a little bit funny. I was tricked a little bit by this case. Haha, funny. Of course I can be tricked. So we got those screws here from the back, and that is the trick. And then you take everything out like this. But those screws of course goes through to the front. And I had the idea maybe I screwed here on the front and then pull out everything from the front, but yeah. So now I need to put in all the screws here on the front again. Well. So here's the tuner. So it's probably just a capacitor in here. We got the two tubes here. There should be one more. So I guess it's in here. There should be a carousel switch for all the different frequency bands. I would love to go and have a look. Oh, we got some stickers, and we also got a little information sticker here. I can't read what it says. Only Grundig and measurement equipment, and then nothing else really. There's not a lot of electronics in here. There's a mains filter right there. And the reason why we got 4 wires here, that's because the mains entry voltage selector is in here as well. And well, let me show you. Of course, this one is switching the transformer between parallel or serial mode. So that's why we got the 4 wires like that, right? So that will be our mains transformer. We got a little rectifier down here and stuff like that. I can get access to some of those screws. Let me see how I can, maybe I can look at the colors here and then take it apart. So we got, this is a blue, gray, black and a red. Yeah, let me do that. This is all pretty much okay. So now I try to open it a little bit more so we can see all the cool internal parts. That is definitely the tuner capacitor. And look at that. That looks really, really weird. So there's something wrong with that capacitor, definitely. But I also find another really bad one down there. Let's see if we can get some light in that hole. That one looks like it is completely cracked. So why is it working with a completely cracked? Why don't you focus? Silly. Yeah, here we go. See? That is definitely cracked. Oh no. That is a very, very beautiful switch. Completely open like that. I kind of like it. That's a very good mechanical construction. Of course it's open. I would prefer a completely sealed one, but... And that is... Of course the oscillator and the carousel. It was quite easy to open the lid to the carousel, but I only see 2 tubes, and there was supposed to be 3 tubes in this one. And look, here's a tube socket that is not mounted. So I think this is the 800 Hertz oscillator that is missing, because I don't have this. It's not working. When I go to 800 Hertz, both here and here, nothing happens. So that is definitely what this tube is supposed to be doing. So there's kind of no other way, right? And here inside this carousel, there's just no way they could have hidden another tube in there. There is no room for that. Looks like it definitely need a lot of cleaning. Oh, no, look at that old gunk of loop that is completely turned itself into all sorts of bad stuff. Oh, you can see one of the diodes down there. I can't really find any of the transistors. There's supposed to be 3 transistors in here, but they're probably in here somewhere, right? 3 transistors and 3 tubes, but yeah. What a disappointment. Only 2 tubes to find. So that's it. But I think I'll just clean it up a little bit more and then assemble everything again. Oh yeah, by the way, earlier in the video I talked about the 4 wires here, where I said it's because they have the primary windings in parallel or in series. That is wrong. The red one is chassis. Okay, so that's different tappings. You can see here it is. Chassis is the red one. And between these 2 is the on-off switch. So that is how it works with this mains. It even says Grundig on the mains transformer. But other than that, it's quite beautiful design. Every component is down here, and Now I need to dig myself all the way into that broken capacitor. That's a little bit annoying. I think I will spare you for the time and trouble to look at that. So thank you very much for watching. I hope you had a little bit fun. Half an hour later, I am in. That capacitor is completely cracked. So how the heck can it be working with this one being cracked? And there's another one right here. And look at that one. It also puked all its guts. So that is a Vima. Maybe they are in family with Rifa. If you know what I mean. But other than that, it's quite beautiful. I don't really like the idea about having all the components in here and then the front, and it took me quite a while to get in here, so this is really, really not service friendly. Could have been another way to do this, right? Just in case if you ever wondered how those gearboxes for the frequency dials they work. So this is a geared shaft. Oh, now I made this dirty again. I just cleaned it so nice and beautiful, but then I put it in some of the gunk here in the paper. Oh no. So I completely disassembled this because it was feeling like it was completely full of chewing gum because of all the lubrication just turned itself into goo or dough or whatever you want to call it. So if you look at this shaft, can you see this really, really cool curve? And then it is flat here on the tip. See here, I got 3 holes for the 3 bearings, and there's a 4th down there, and there's actually also a little spring in here, and this spring stands on the end of that pin. So this is just an isolated output shaft that goes to the capacitor. So this is better for isolation or less radiation and stuff like this, less coupling to the capacitor. You definitely want that. And you need to mind those 2 grooves. That's for the 2 locking. So because there is a spring here, so that means this one fits perfectly in here, and then it stands on the ball. And then see, there's a little springy, but it's really, really a tough spring. So because we got 3 balls, that means due to this angle, the spring is going to push this one is out. It's going to try to push this out, right? And then it's going to connect real good to the 3 ball bearings. And then, oopsie doopsie. See, now I can't put it back unless I push real hard. Oh. See, now it's in. So here we got the groove for the 2 locking, and also the 2, I think this is copper bearings, but you should see the point now. Maybe I should do like this. So now there is the There's no friction here. I mean, there's no hysteresis, mechanical hysteresis. And there's a super good feeling. It runs so smooth. Now it's cleaned. And now I can assemble my unit again. So that is how it's done. And this can of course be made in many different ways, depending on how they want to do it. But in general, the idea is with the ball, it pushes this one around. Nice gearbox.